So in the last video we discussed about how the metal is refined, which means the concentration or dressing of the ore is discussed in the last video, right? So in the concentration means there are some impurities called gang, which means, for example, take sand and soil. So these are called impurities called gang. How the gang or the impurities, rocky material, will be removed from the ore, so that is called concentration method. In this method we will discuss about the ore will be concentrated or dressed by using different methods like hand picking is there and washing is there, and mainly froth flotation method as well as magnetic separation method. So all these methods are discussed in the previous video. And now here we are discussing the extraction of crude metal. So how the extraction of the metal will be available, how we are extracting the crude metal from the ore, we are discussing this topic in today's class. Generally the extraction of metal from its ore is depend upon the reactivity of the metal. So it is very important point. So already we discussed, basing on the reactivity of the metals, generally metals are classified into three categories: highly reactive metals, moderately reactive metals, and less reactive metals. So this categorization is based on the reactivity. So here this concept is very useful in the extraction of crude metal, because the extraction of the metal is depend upon its reactivity. By depending upon it, the reactivity of the metal, we can extract the metal. So we have no highly reactive metals, generally sodium, potassium, magnesium, calcium, and aluminum. All these are comes under highly reactive metals. And moderately reactive metals, generally zinc, copper, iron, tin, lead. So all this comes under moderately reactive metals. Whereas the less reactive metals means, we know it very well, gold and silver. So these are comes under less reactive metals. We know it very well. So to understand the order of reactivity of metals, we should study. There is a table for the reactivity of highly reactive metals and moderately reactive metals and less reactive metals, which means if the with oxygen, how the highly reactive metals will react, and what will be the product when the moderately reactive metals react with oxygen, and how the less reactive metals react with oxygen. Not only oxygen, with the cold water and hot water and acids, in presence of chlorine, how the all types of metals we react to. We have a table to understand. See here, first the potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, mercury, silver, platinum and gold. So these are the order of the metals. So up to aluminum, these are highly reactive. From zinc to mercury, these are moderately reactive. And gold, platinum, silver, these are less reactive metals. So the reaction, which means when the reaction with oxygen, when the potassium and sodium react with oxygen, it gives Na2O, K2O, means disodium monoxide and dipotassium monoxide will give the product. So here when the calcium, magnesium and aluminum when the calcium, magnesium and aluminum react with this, so they form calcium oxide, magnesium oxide, Al2O3, ZnO, Fe2O3, like this. So here the O2 at the less supply of oxygen, they react with like this. At more in excess presence of oxygen, they will form peroxides. So like this, the metals will react with different ways. See, if in this case PbO, copper oxide, HgO, so these will also form. whereas in case of silver, platinum and gold, they do not give any reaction. See, reaction with cold water and reaction with steam, reaction with dilute strong acid and reaction with chlorine on heating. So like this you have to just read the table given in your textbook and you have to concentrate, which means generally highly reactive metals gives they react with somewhat with all elements, but whereas the moderately reactive metals gives some less reactive nature. The less reactive metals, they may not react in any case. See, if you see here, all metals react with chlorine on heating to form the respective chlorides. Is it okay? Whereas if you see here, KCl, NaCl, CaCl2, MgCl, Al2Cl3, ZnCl2, FeCl3, VbCl2, which means all metals may form chlorides: potassium chloride, sodium chloride, calcium chloride, magnesium chloride, aluminum chloride, Al2Cl3. Like this all may react with the chlorine atom. Is it okay? So when you react with strong acid, when you see here, copper to aurum do not display H2 from dilute strong acids, whereas copper to lead displacement of H2 from dilute strong acids and decreasing the reactivity. From potassium to gold, when we are observing, the reactive nature is decreasing. So that is why in all cases also the reactivity nature will also decreasing. When you see with cold water, potassium to magnesium displace hydrogen from cold water, which means in cold water there is a H2O. In H2O the displacement of H2 is there. But from aluminum to aurum there is no displacement of H2 molecule. So reaction with steam. So potassium to ferrum displace H2 with steam without decreasing reactivity. But when you see Pb to aurum, there is no displacement. So like this you have just concentrate on the table. Okay, this is what the reactivity of metals from high to low, which means potassium, sodium, calcium, magnesium, aluminum, up to these are highly reactive metals. And from zinc to mercury, these are moderately reactive. From silver to gold, these are less reactive. So when you observe here, the arrangement of metals in decreasing order of the reactivity is there. So this is called activity series. So you have to remember the word. What is activity series? Activity series means, see, the arrangement of metals from top to bottom in decreasing order of their reactivity. So this nature is called activity series. So now we have to know what is the activity series. So activity series means the arrangement of metals from high reactive nature to low reactive nature. So this is called activity series. So basing on the reactive nature of the metal, we can understand how to extract the metal, crude metal from the ore. So first we are discussing about in case of highly reactive metals. See, the first method is highly reactive metals. What are the highly reactive metals? Generally potassium, sodium, calcium, magnesium, aluminum. So to extract these highly reactive metals from their ore, generally we are preferring reduction process. So it is very important. So what is reduction process means? Reduction means heating of the ore with with carbon or carbon monoxide. So when we are heating these metals, potassium, sodium, calcium or magnesium, aluminum, with carbon or carbon monoxide to reduce the ore of these metals, so it is not feasible, which means at low temperature it is not feasible. So for this high temperature is required. So with high temperature and this reduction process may be highly expensive. Is it clear? So the reduction of highly reactive metals are generally followed by the reduction process. Reduction means heating of the metal with carbon or carbon monoxide generally. But in this case, the lower temperature is not feasible, which means these are highly reactive metals, So because of the reactivity nature, they are not feasible at the lower temperature. So for this, high temperature is required. If the temperature is required more means the reduction is too high, which means it leads to the highly expensive method, more expensive. So to make this process is very difficult, so that is why there is an alternative method is there, so that is called electrolysis. Electrolysis method is preferable, which means the highly reactive metals like potassium, sodium, magnesium, all these are extracted by the electrolysis method. Again, this electrolysis of their aqueous solution, which means electrolysis means the ore is electrolyzed. So but here the aqueous solution is also not feasible, because when we take the aqueous solution of the metal, the ore in the solution would be discharged at the cathode. So that is why here also this method is not applicable, which means the only method available to extract these metals by electrolysis of fused compounds. So it is very important. So I will explain once again. See here, the extraction of crude metals, first we are taking the highly reactive metals. So generally to extract these highly reactive metals by using the reduction method, but when we see in the reduction process, the metal is reacting with carbon or carbon monoxide at lower temperature. So because of at lower temperature, because of their high reactive nature, at lower temperature they are not feasible. So for that high temperature is required. So for high temperature means it requires more energy, which means it is more expensive. So to overcome this, electrolysis method is adopted, which means which process is used to extract the high reactive metals, which means that is electrolysis method. So here we have to remember one point. The highly reactive metals are extracted from ore is by using electrolysis method. Again in this method, the aqueous solution is not preferable. Only fused compounds will be taken in the electrolysis process, because the aqueous solution, if you are taking the aqueous solution in the water, while we are taking in the water, the metal is deposited at the cathode. So that's why here only the fused compounds will be taken in the electrolysis process. So let us see one example. Here we are using the electrolysis process to extract the sodium metal from the NaCl fused compound. So we are taking the fused NaCl here. So this is fused NaCl compound. NaCl compound we are taking by electrolysis process. Here this steel is acting as a cathode, whereas the graphite is acting as an anode. So when the NaCl is present in this, if you are taking NaCl, and at the cathode the metal Na plus is deposited, whereas at the anode the anion chlorine is deposited at the anion. So it is non-metal. Chlorine is a non-metal, we know it. So the metal is deposited at the cathode, which means at cathode the sodium becomes sodium plus by losing 2 electrons, whereas at anode the chlorine becomes chlorine minus by gaining those 2 electrons. So this process is happened in the electrolysis process of sodium NaCl. From NaCl, the sodium metal is deposited at the cathode. It is extracted by this method. So again, in this electrolysis also, a large quantity of electricity is required to keep the ore in the molten stage. Which means if the large electricity is required means it is more expensive. It takes to more expensive. So to overcome this, some impurities, suitable impurities are added here. Impurities. So because of these impurities, the ore is not decreasing its melting point. So this is what the electrolysis of sodium from sodium metal. By this method, not only the sodium chloride, highly reactive metals like magnesium chloride, from magnesium chloride, magnesium and Al2Cl3. So highly reactive metals are extracted from their ore by using the electrolysis method in the molten stage, in the fused compound. So this is the first method. And now let us see the extraction of metals in moderate reactivity. So the second case, extraction of metals in the middle of the activity series. Generally in the middle of the activity series there will be zinc, ferrum, tin, lead, copper, etc. So these ores of these metals are generally we know it, zinc, ferrum and copper. Most of the these metals are present in the form of sulfide ores and carbonates. Already we discussed, because sulfur is a chalcogen metal, so that is why most of the metals will be present in the form of sulfides and carbonates in nature. So first we have to extract the metal from the ore, means we have to change their forms, because they will be exist in the nature as a sulfides and carbonates, right? So therefore it is prior to reduce the ore of these metals, they must be converted into metal oxide. So a very important point. So if you understand this, then only you will be understand the next methods. So generally we have discussed already zinc, lead, tin and lead, ferrum, copper. So all these are moderately reactive metals. They will be present in the nature in the form of sulfides and carbonates. So to extract the metal from their sulfides and carbonates, we first convert into them as a metal oxides. So very important point. When any metal is present in the form of a sulfide, for example zinc sulfide is there, or copper sulfide or PBS. So it is in the form of sulfide. So to extract the zinc from the zinc sulfide, first you have to convert into oxide, metal oxide. Then only you will be extract the metal easily. So you have to first convert into zinc oxide, then you will be extract the zinc metal from that oxide. So for changing or for converting the sulfide ores are converted into oxides by how the sulfide ore, for example take the zinc sulfide is there. So this is the ore. So to convert into zinc oxide, what is the process here? Which means here these sulfide or carbonate ores are converted into oxides by heating them strongly with excess of air, which means in presence of oxygen we have to heat it. So this method is known as roasting. So very important. So there will be question in your exams. If you see your previous exams, there will be question about roasting. What is roasting method? So generally roasting means we have to heat the ores, sulfide ores or carbonate ores in the excess of oxygen. Then we will get the oxide form. So that is called roasting. See here, roasting. Roasting is a pyrochemical process in which the ore is heated in the presence of oxygen or air below its melting point. The products like metal oxide from sulfide ore obtained in the process also are in solid state. Generally reverberatory furnace is used for roasting. See, This is the reverberatory furnace. So here question will be like this: which furnace is used in the roasting process? So undoubtedly it is reverberatory furnace. So in the roasting method, which ores are converted into oxides? Means sulfide ores or carbonate ores. So here if you see the zinc sulfide, by heating the zinc sulfide with excess oxygen, we get zinc oxide and sulfur dioxide. So from the zinc oxide, the zinc metal is extracted easily by heating again in the oxygen. So this is called roasting method. So we have idea about roasting. So roasting is a process. It is used to convert the sulfide ores to metal oxide. Is it clear? So now here take the PBS, lead sulfide. It is heated with excess oxygen. So we get 2 PbO metal oxide and then 2 SO2. So here we getting the metal oxide. See, these metal oxides are again reduced to the corresponding metal by using the suitable reducing agent like carbon or whatever it may be. So we get, by heating again the metal with the reducing agent like carbon or the carbon monoxide, we get Pb plus CO. See here, the first we are doing is roasting method. Just wait. So here in this case, first we are doing the roasting method. Roasting method means we are converting the sulfide ore to the oxygen form, metal oxide form. Then we are again doing the reduction method here, which means the sulfide ore is directly not converted into, not giving the metal. So if you are getting the sulfide ore, it will be converted into metal by two methods here. The first method is roasting. In the roasting method, we are converted into sulfide ore into metal oxide form. Then again we are reducting the metal oxide with using the reducing agent like carbon or carbon monoxide, we get the metal. So this here, the reduction of metal oxide with carbon. These oxides are reduced by using a coke or carbon. Here closed furnace is used. Which gives the metal and carbon monoxide. Why here closed furnace is used? See here in the roasting method there is a reverberatory furnace is used, right? But in the reduction method we are using the closed furnace. What is the difference between the reverberatory process and closed method? See here in the roasting method there is a excess supply of oxygen is there. But whereas in the case of the reduction method there is limited supply of oxygen. Heating is there in two processes. But in the first case roasting method there is a reverberatory furnace is used because here excess supply of oxygen is there. But in the reduction method we are using limited supply of oxygen. So that is why we get closed furnace means here not allowed the excess oxygen. So we get the metal. So this is the one method, one of the best method to reduct the metals which are present at the middle of the activity series, like zinc, copper, iron and tin, lead. So all these metals will present at the middle of the activity series, and these metals will be extracted from their metal ores in the form of roasting and reduction method. Let us see one more example. So for example, reduction of oxide ores with carbon monoxide. See, we have discussed already the reduction method is used to why it is used means to convert the metal oxide to the metal form. So reduction here, in the reduction process, generally carbon or carbon monoxide used as a reducing agents here. So in the first example, in case of lead oxide, we are using the carbon as a reducing agent. But the reduction of oxide ores with carbon monoxide, take Fe2O3. We are using 3CO in the, it is heated in the blast furnace. We get 2Fe plus 3CO2, which means by reduction method we are getting the metal. The metal oxide is reduced to metal by reduction. So here this reaction is takes place in the blast furnace. So you just concentrate on all the processes which we are using in the middle elements which are present in the activity series. So in the first case, there is a roasting method is there. In roasting method, there is a reverberatory furnace is used. And the second, in the reduction method, reduction which presence of carbon, so here closed furnace is used. But reduction with carbon monoxide, blast furnace is used. So you have to remember all the furnaces. And next, let us see one more example. So here, auto or self reduction of sulfide ores. So take one example, 2Cu2S plus 3 oxygen, it gives 2Cu2O plus 2SO2. So here the metal sulfide ore is converted into metal oxide in the partial heating. Here what happened? In the extraction of carbon from its sulfide ore, the ore is subjected to roasting here. So here means this process is called roasting, first method. Because here it is heated with excess oxygen. So here partial roasting takes place here. Then it will convert it into, the sulfide ore is converted into metal oxide. So now how this metal oxide, when the excess supply of air is stopped and temperature is raised. See here what happened here, oxygen is excess supplied and temperature is partially heated it is. Because the roasting process here, the partial temperature takes place here, we get the oxide form. When suppose if the air is stopped and the temperature is raised, then the rest of the sulfide ore react with the oxide, which means like this, and we get 6Cu plus SO2, which means what happening here, generally in this in the first step here the roasting takes place. Roasting means the Cu2S, it is the sulfide ore of copper, it is heated with excess oxygen and we get oxide form here. So here partial roasting takes place in this case. If the heat is reduced and oxygen, if the heat or the temperature is raised but oxygen supply is stopped, so in that situation the remaining copper sulfide is there, so that is again reacting with the copper oxide. So this oxide is react with again ore, we get the copper. So this is called auto reduction or self reduction of sulfide ores here, because again the sulfide ore takes place in the reduction. So that is why it is called auto reduction method or self reduction. So this is one of the important method. So the next one is reduction of ores by more reactive elements. So it is very important. Generally we have sodium, potassium, aluminum, magnesium. So all these are more reactive metals. So now reduction of ores by more reactive metals. So this process is called, it is very important process, and it is called thermit process. So this thermit process generally involves the reaction of metal oxides with aluminum. Generally, when highly reactive metals take sodium, potassium, calcium, magnesium, aluminum, etc., these are used as here reducing agents here. So the question will be like this: in thermit process, what are the reducing agents used in thermit process? So in thermit process, the more reactive elements, metals like sodium, potassium, calcium, aluminum, magnesium, all these are used as a reducing agents. So the ore compounds react with these reducing agents and displace metal of lower reactivity from the compound, which means in the thermit process there is displacement takes place. Take one example. Titanium chloride is reacting with 2Mg at 850 degree temperature. It gives titanium plus 2MgCl2. So in this reaction, the magnesium is act as a reducing agent. So this is called reducing agent here. And the displacement reactions are highly exothermic. So these reactions, take one more example. Titanium chloride plus 4Na gives rise to, at 850 degrees centigrade temperature, it gives titanium plus 4NaCl. So in the two examples here we obtain the metal, but here the titanium is reacting with the more reactive elements, right? So these reactions are called exothermic reactions, and the process is called thermit process. So the amount of heat evolved is so large that metals produced are in molten state. So in these reactions, the metals which are obtained are in molten state. So this is called thermit process. Take one more example. So if you observe the two reactions here, 2 aluminum plus Fu2O3 gives rise to Al2O3 and ferrum and heat produced. In the same way, 2 aluminum plus Cr2O3, Al2O3 plus 2 chromium plus heat produced. So if you observe here, the reactions like the reaction of ferrum with aluminum produces molten iron. This is in molten state because here the heat produced is very high. So that is where the metal produced in the reaction is in molten state. So it is used to join railways. So it is very important. In your competitive exams, there will be question from this reaction. So in the railways, these molten state metal or iron is used for railway tracks. So this reaction is called thermit reaction. So this process is used in the railway tracking. So for welding purpose, here these railway tracks are cracked, the machinery parts like this. For welding purpose, the metals which are produced by the thermit reaction are used in this process. So in the above reactions we get the ferrum, and this ferrum is in molten state. This is used in welding railway tracks and in the machinery parts. So this process is called thermit process, and the reaction is called thermit reaction. So in the thermit reaction, the heat produced and the metals obtained are used to railway tracks for welding and other machinery parts. So this is one of the important application you have to remember. And now let us see the next one. So the next one is the third part. Already we discussed extraction of metals which are at the top of the activity series. Top of the activity series means reactive metals, high reactive metals. In the second case we are discussed moderate reactive metals by different processes. And now we are studying about the extraction of the metals at the bottom of the activity series. So we know already the silver, mercury, gold. So these are at the bottom of the activity series, which means they are less reactive. Most of the metals do not participate in any reaction because all these are very less reactive metals. So now few of the metals from the bottom of the activity series also may participate in some reactions. So let us see which of them we are obtained or extract. So metals at the bottom of the activity series are often found in the free state. So the reactivity with other elements is very low. We know it. So the oxides of these metals can be reduced to metals by heat alone and sometimes by displacement from the aqueous solution. For example, take one example. So 2HGS plus 3O2. Heat is given. We get 2HGO plus 2SO2. And now this 2HGO, again heat is producing 2Hg plus O2. So if you are observing this equation reaction, HGS means cinnabar. So which is one of the ore for mercury, right? So this cinnabar, from this cinnabar ore we have to extract the mercury. So what we are doing means this cinnabar ore is heated in presence of excess oxygen. So here so here first this sulfide ore is converted into oxide ore. Here the roasting process will be taken up because the sulfide ore is heated in presence of excess oxygen, then we get the oxide, metal oxide. So now this metal oxide is again heated, we get the mercury and oxygen. So this is one of the extraction of metal which are present at the bottom of the activity series. So now let us take one more example. So the second example is displacement from aqueous solution. So here take Ag2S plus 4Cn minus gives rise to 2 AgCn twice minus plus S minus 2. So here displacement will be taken Ag and Cn. AgCn twice plus sulfur. So again this AgCn minus 2 is reacting with the zinc. So here zinc is called reducing agent. So the zinc powder is added as to this AgCN minus aqueous solution as a reducing agent, and we get ZnCN4 minus 2 and Ag. So we get the silver. So here Ag2S is there. It is dissolved in the potassium cyanide KCN solution to get dicyanoargentate So here this complex product is called dicyanoargentate. So this is we get, and now the from these ions the argentine precipitate is removed by treating with zinc as a reducing agent. So this dicyanoargentate aqueous solution, the zinc powder is added as a reducing agent and we get the silver. So this is what the extraction of metals which are present at the bottom of the activity series. Generally the bottom activity series may not participate in any reaction, so that is why it is somewhat easy to extract. So here in this case we are discussing two examples. So the first one is called HGS. From the HGS we are removing Hg, we are extracting Hg, and then the second example, that is silver. And next, so earlier we have discussed that the extraction of metals from the ores is involving three stages, right? So the first stage is concentration and dressing. Concentration means nothing but we are removing the impurities. Impurities means nothing but they are called gang, right? Which means sand, soil, all those things we are removing in the first stage. So here also there are a lot of processes are there to remove the impurities. So depending on the different types of ores. So in the second stage, extraction of the crude metal, which means some metals may contains different metals, other metals as impurities, and some ores may contains different metals and non-metals including. So we have to extract that particular crude metal from that ore. So to extract that particular crude metal we are following some methods like roasting, we know it, roasting and reduction and self reduction and try. So there are different types of metal thermit process, all we are discussing now. So now the last step is refining of the metal. Refining means nothing but purification, purifying, which means after the third stage we get 99.9% pure form of metal, because this is the last stage. After extracting the metal, crude metal from the ore, the crude metal means it contains less number of impurities now, and now some of metals may contain as impurities. So the final stage, in this third stage, the total number of impurities will be removed. We get the pure form of metal after the third stage. So that is very important, refining of the metal. So now let us see how to refine the metal. So the third step is called purification of the crude metal. See, generally the metal is obtained by the reduction of the ore is usually contaminated with impurities like uncharged ore. And sometimes other metals may also present in that particular crude metal, in that ore, other metals or non-metals. So now in this stage we have to remove that sort of impurities. Take one example. So the copper, it is called blister copper. So the blister copper is obtained from its sulfide ore, which means, so it is copper iron pyrites, CuFeS2. So this is called copper iron pyrites. From this ore we are extracting the copper metal, but it contains some copper sulfite and iron and sulfur. So now it is purified by suitable methods. So we are extracting only the copper metal, but it may contain some copper sulfide and at the same time ferrum and sulfur also. So to remove all the impurities, so it is purified by suitable methods including electrolysis. So now what is called refining? So refining means nothing but the process of obtaining the pure metal from the impure metal. So this is called refining of that metal. So which means the ore may contain pure metal as well as impure metal. Is it clear? So we are refining that pure metal from that impure metal. So that process is called refining. So that is the third stage. Refining means purifying. And now this refining of the metals also may having several types of processes. So now in that processes we are discussing few more examples. Let us see. So some of refining methods are there in your textbook. So first we are discussing about the distillation method. So in this method is very useful for the purification of some metals like zinc and mercury, because see these zinc and mercury may contains low boiling points, right? So such type of metals may be refined by this using the distillation process. So for example, see in this case we are taking the metals like zinc and mercury because they are containing the low boiling point. So here this method is very useful for purification of low boiling metals like zinc and mercury, which are containing high boiling metals as impurities. Which means in case of zinc and mercury, these metals are containing low boiling points, but in these metals, what are the impure metals are there? Those impure metals or impurities may contain high boiling point, right? So the extracted metal in the molten state is distilled to obtain the pure metal as distillate. So when we are taking that metal here, while heating, after heating, because of the low boiling point of zinc and mercury, they are evaporated. Like this, by vapors, we get here the pure metal. Is it clear? Whereas the impure metal having high boiling point, so due to it is deposited here. Deposited means it is present at the bottom of this container. So this process is called distillation. Distillation means the metals which are having low boiling points like zinc and mercury, this type of metals are refined by this distillation process. Why? Because these metals may containing the impurities with high boiling points. I think we know what is the boiling point. Boiling point means nothing but at what temperature the liquid turns into vapor. So at low temperature only this metal is converted into vapors and we are collecting the pure metal here. And the impure metal, impurities is deposited here. So like this we are separating the pure metal from the impurities. So this is one of the best method. And now let us see the second one. So here the second method is called poling. In this method, take the metal in the molten stage in this container, and this metal is stirred with the poles of green wood. So is it called logs or poles maybe? So it is stirred it very like this. So after that the impurities are removed either as gases or they got oxidized and form slag over the surface of the metal molten state. Example is blister copper. In this method up to 98% of copper is obtained in the poling method. Because here in this case the metal is in the molten stage, while we are stirring with this green log or pole, the impurities are removed by gases or they got oxidized and settled at the surface of the molten metal. Then we obtain the remaining purified metal at the bottom, we collect it. So best example for this poling method is called blister carbon. So by which method we get the purest form of copper? So is poling. In this poling method we get 98% of pure form of blister copper. So this is one of the best method. And now let us see the third one. So the third method is called liquation. So in this method generally the metals which are having low melting point. Example is tin. So it can be made to flow on a slopy surface to separate it from high melting impurities, which means some metals may containing low melting point and those metals impurities may have high melting point. So here MP means melting point. Melting point means at which temperature the solid turns into liquid is called melting point. We know it very well. So take these metals. So this is the slopy surface. So now apply heat here. By heating, so take this metal on this surface, slopy surface. By heating, the impurities, because the impurities having high melting point, they are settled here. But the pure metal having low melting point. So that is why because of the low melting point, we will collect the metal, pure metal at the, like this. We get the pure metal here because it is settled here because of low melting point. So by this method, the best example is tin is extracted or purified. In this method, liquation method, tin is purified, whereas the poling method, copper is purified, whereas the distillation method, zinc and mercury can be purified. You have to remember the examples. And now the fourth one is called electrolytic refining method. Let us see. So the fourth one is called electrolytic refining. Generally in this method, copper is refined. How it takes place? Let us see. So take two electrodes. In this metal, the impure metal is made to act as anode. So we have to remember is impure is anode, whereas the pure metal is cathode. So a strip of the same metal in the pure form is used as cathode. So they are put in the suitable electrolyte and the electricity is given to connect like this. So the required metal, what happening here? They are put in the suitable electrolytic bath and containing soluble salt of the same metal. So what we are taking here, impure is anode and pure form is pure metal is at cathode, right? The required metals get deposited on the cathode in the pure form. The metal constituting the impurities goes at the anode mud. So which means we are taking the same electrolytic solution. So by electrolyzing it, the pure metal is deposited at the cathode and the impure is deposited at the anode. For example, take the copper. So for copper, we are using this electrolytic method to refine copper. For this, an impure copper is taken as anode. So here anode is impure copper, whereas pure copper strip is taken as cathode. Is it okay? So the electrolyte is acidified solution of copper sulfate. So here the electrolytic solution taken is copper sulfate. So it is very important. So here the taken electrolyte solution is copper sulfate. As a result of electrolysis, copper in pure form is transferred from the anode to cathode. So what the copper particles are present around the anode is also transformed from to cathode and deposited on the cathode in all the directions like this. So reactions at anode. which means copper is gives rise to copper plus 2 electrons. At cathode, copper plus 2 reactions and becomes copper. So the soluble impurities goes into the solution, whereas insoluble impurities from this blister copper get deposited at the bottom of the anode. See here in the copper sulfate, the copper is deposited at the cathode, whereas the impurities are deposited at the anode. So like this, the copper is refined by using the electrolytic refining method. So in this, what are the impurities? The impurities may be like antimony, selenium, tellurium, gold, silver, platinum, etc. They are deposited at the cathode, at the anode, bottom of the anode. So recovery of these elements may meet to the cost of refining. So this is the one of the best method to refining the copper by electrolytic refining, and also zinc may also be refined in this way. So which means the simple process. Here the electrolyte is taken the copper sulfate. So the copper sulfite, from that copper sulfite, the copper is deposited at the cathode, pure metal, whereas the remaining part is deposited at the anode as a mud. So like this we are refining the pure metal by electrolytic refining. So this is what the electrolytic refining method, and all the refining methods are concluded here from here. So we will discuss the next topic in the next class.